So I'm Nick from Vire Engines. I just wanted to discuss and compare the Dolphin marine engine, which is a very similar idea to the Vire. Um, I've just got this one in because it was thrown out of a boat for repeatedly having cylinder head failures, and apparently they all go like this. And the customer's taken delivery of a Vire 12. So very happy with that. I just got this out of curiosity for a few quid, and I wanted to see if there was anything on this engine which could be incorporated into the Vire in future, being open-minded. Anyway, I've had a good look at it. I can't say I've read the manuals or anything, so this is just my opinion anyway. But I've come up with like a list of unusual things about this engine, and it might be worth considering what's so good about the Vire. This is a Vire. I'm just building this concourse one. I've done the engine. This cylinder head, as you can see, is one piece casting. There's no joint for a head gasket, and so a head gasket can't fail. Now, what they've done on the Dolphin is, I'll just take this ignition out, which is controversial. Got an aluminium cylinder head, presumably to save cost and weight, and a cast iron cylinder. So you're joining dissimilar metals. Now, if this was a car, and I know because I've built literally hundreds of engines, if this was a car, the head gasket, which you squash down with powerful bolts, has a steel seal in the plastic, and so you get a really nice high pressure seal where you need it between the cylinder head and the cylinder block or cylinders. Now, what I notice on this is a brand new, supplied by Dolphin recently, head gasket. He only decided not to even try it because he was fed up of it boiling up. It's a design fault. Now, I can say that because I've got an engineering degree in maritime technology, and I'm an expert marine engine builder with petrol two-strokes, and that is a design fault because it hasn't got the capability to seal the high pressure. We're talking ridiculous PSI. When that goes pop, talking about over 1,000 PSI at the edges. So it's just going to gradually creep through this semi-porous carbon gasket until it reaches the waterways. It's just a matter of time. And you've got salt water here, not normal car water, which is antifreeze water. So this is corroding through. Because of the dissimilar metals, it sets up a micro voltage between the two constantly, and you get electrolysis. This has been repaired, but the owner wasn't happy after it was done. It's going to fail again and again. But even where it's not failed, you can see the pitting starting microscopically. And that's due to the fact that the gasket is all best going to be slightly porous after some use. I was intrigued to see in their old printed manual that when this was initially launched, it only gave 2-year guarantee on this engine. So I think that's why. Now, you have to ask the question, why didn't they design this with a matching cast head of similar metal? Why did they go aluminium? I'm not sure really, but I know aluminium draws the heat away a little bit better. And these pistons and the amount of heat is always an issue at 12 horsepower. So it might have been that they were worried that a steel head wouldn't have drawn the heat into the water quick enough, and aluminium is more effective. It could also have been a lot cheaper to cast such a complicated hollowed out shape using lost wax system with this, whereas you can cast these straight things in sand a bit easier. So this doesn't lend itself to sand casting with the expanded recesses in there. So if you're going to cast that economically, you'd probably do it with aluminium. So certainly save cost, drew the heat away, but it's going to corrode again and again. So this is the whole weakness of this engine. and why it failed and was thrown out, because even with a new gasket and a new head, incidentally, these are about £500, I understand, just for the head, and there's a load of machining that needs doing, because that's just a raw casting. You then need to get it all machined in various ways. I don't understand that, I confess, but it was the only choice the owner had, was to replace the head to solve this problem, and he just didn't think it was worth it, because likely it's going to go again in a couple of years. Now, some interesting comparison with the Vire. No joint, no dissimilar metals, cannot fail. And this is surrounded by water, much more water, I think, than passes through the Dolphin. And on the failure rate, I've never been a failure of a cylinder head gasket. You don't need a cylinder head gasket. You just take the pot off, and there's a low pressure seal here, which is a special kind of paper, not this compromised gasket. And I say compromised because there's no high pressure seal in where it needs it. Shame, really. So what are the other things we could learn? So it's got contactless lumination. I notice that this hole is open to the elements, so if you've got a water leak, it could go down there and damage the sensor. And then how are you going to get that out? You'd have to take the whole crankshaft, belts, wheel off, and this block that they've put the contactless breaker in is an integral part of the support. So you'd have to disconnect the support, and then once you've taken off that, you'd probably expose the front oil seal on the crankshaft. Not a good situation, so that really needs to be sealed up waterproof, not like that. I mean, I respect the fact that they've got a lumination unit on there, so it's going to give a better spark, and maybe that's waterproof and potted inside there, I can't see, but it seems to be a bit odd that you've got a cavity that could fill up with water right where the ignition sensor is. You've got a jab scope pump kind of on the front here. Now, you'd think that was a good thing, because sometimes people need to change the impeller, but what I'm worried about is the gauge of this drive belt, and it's on aluminium pulleys. Now, any kind of corrosion, which of course occurs on aluminium, is going to make that belt chaff and wear. It's very thin. So if that breaks, the cooling breaks, the first thing that's going to go is your head gasket, and we know that's trouble. It might be easy to replace, I can see that, but if there was no joint there and it overheated, it would be a lot more tolerant. I know the Vire is very tolerant if people forget to put the pump on, because there's a heck of a lot of metal to take the heat away anyway. Trouble with aluminium, there's not enough mass there to absorb the heat and radiate it through the castings, because you've disconnected the heat path with the gasket as an insulator. When the head gets hot, it just warps, because the heat is not being sucked through the rest of the heavy cylinder and casings. On the Vire, that's not true. If this was to overheat, most of the heat, of course, is near the flame, which is in the top. It gets drawn down to the rest of the cylinder through the studs into the main engine block, so you've got a better chance of surviving accidentally losing cooling pressure. So I like the way they've geared it down, because if you do a jabs go too fast, it's trouble. And notice they've got a overheating warning sensor here, probably because that was a common issue. The Vire doesn't have anything like that, because it wasn't a common problem, overheating. They are pumping the raw water through an aluminium exhaust manifold here, which is a good idea in principle, but not in terms of reliability, because you've got very hot things and it'll cool down and empty. So when the engine stops, you may get airlocks and corrosion in here. I bet that's been an issue. And it's similar to the Vire in that design, but what I'm concerned about is this is bolted onto one of the hottest parts of the engine here, where water is passing through as well. So again, you can see somebody's bodged up with silicone adhesive. The holes in this side of the manifold are probably subject to corroding and changing shape, and then what do? So you've got a motorcycle starter motor, and you've got the solenoid above it right underneath the water fixing, so any kind of drip or leak starting on this manifold heat exchanger or these pump clips is going to drip straight onto the main electrical connections here and start corroding them. So I don't know why they've put that there. It really should be away from the engine in a dry place like on the bulkhead. So I bet that's been an issue before. The mounting points are not rectangular. They're nice and straight at the front, but if you look at the back pair, they're offset because the gear stick control on the Hurst gearbox got in the way, so they couldn't put it here to match the other side. So it's a bit of a fiddle getting the positions down. It's not just a simple rectangle. The alternator is to charge the battery because a motorcycle starter won't do this. Obviously on the Vire engine you've got Dynastart. Lots of interesting things about Dynastarts. One of which is the Dynastart doesn't cause any significant drag at low idle RPMs. If you've got a flat battery or a fully charged battery, it's the same drag. Alternators can't do that. As soon as you blip the throttle the first time the engine's running, it cuts in, and if you've got a flat battery, it tries to charge it at maximum amps, which creates quite a bit of drag, slows down the crankshaft, and either stops the engine or you have to adjust the carburetor to keep it going. And then when the battery's charged, there's less drag, so the engine revs too high in neutral. So you'd have to adjust this again. Now the way that they've solved this, I've seen this before, is instead of having a 2 or 3 to 1 speed up ratio for the alternator, they've done it nearly the same speed as the crankshaft. So this is basically not going to charge at all until it reaches mid revs, which means it's never going to get to full RPM. I doubt that this 550 watt alternator ever produces 550 watts, even when this engine's running max, because it's not spinning fast enough. And the reason they've done that is because it would cut the engine out at idle if you had a flat battery. So they basically disabled this alternator 50%, so it doesn't cause such a big torque drag with a flat battery. Now if you had a Dynastart, it can't do that. It has a progressive drag or torque curve depending on the speed. It doesn't change much if the battery's flat because it's simply not charging at idle RPM. And so I don't think they've saved any weight with the combination. The other issue is that this doesn't appear to be a marinized alternator, and even if it was, the salt air is blown through the windings and corrodes the castings, the bearings and the windings like hell. On the Dynastart, there's no air going through it. It's protected against the elements. It'll last much longer on a boat. So this is also something you wouldn't need to fiddle with much, apart from adjusting the belt tension, but it's right in the way of getting down the back here to the carburetor. So if you want to clean the carburetor out, because you may have ingested some rust from your fuel tank or something in there, that's very difficult. You'd have to undo the neck screw, pull it out, disconnect the throttle screw, and then you could put it on the chart table or whatever to clean it out. But it might be that they could have put this on the front of the engine instead. Would have been slightly noisier for the occupants, but it would have been a lot easier to service the carb. So I think the reason was simply they had the pulley at the front. If you look at the Vire, the carburetor is right up here, right where you can get at it. You can change all the linkages, the adjustments, same with the gear stick. With the Dolphin, it's all very deep behind. I don't know how you would get down there and adjust the linkages for the gears or the throttle. The only way is to basically make sure there is a hatch you can lift up in the aft of the boat, which this gentleman had, but obviously that compromises your safety in a storm where that removable hatch can leak or even blow off and sink the boat. Most boat builders recommend that there isn't a resealable hatch in the cockpit because it's self-draining and they don't want any issues, plus it weakens the structure of the boat a bit. So with the Vire you wouldn't need that. One of the arguments a Dolphin's better is it's got the pump at the front where you can get at it, and on the Vire of course it's right at the back, down here on the back. Now they have had problems in the past because of badly made impellers and pump shafts that corroded. It's true. So you get down the back of the engine and this housing comes off. It's not removed here and you have to deal with it. It's very awkward on a Vire if it fails. Now it's never failed since I've been supplying properly made impellers that don't come unglued and stainless steel pump shafts that don't corrode. So the whole argument of having a pump on the front of the engine is based upon the assumption the pump is going to fail and need servicing. But in my experience now, over 10 years, supplying hundreds of these impellers, not one has failed, and owners have not needed to service the pump, which is hidden out the back. And it gives you more room because then you've got the dyno start in this position on the Vire, which leaves the starboard side clear for the carburetor. I love the layout of the Vire. So this is really a modular engine. It's got someone else's gearbox, which is made by ZF Hurst. They're about £1,000 to replace alone. Consequently, the costs go up if you have to buy something in rather than manufacture it. This is a Mitsuba starter motor, which is bought in. It's motorcycle origin, I'm pretty sure, or it could be one of these marine diesel starters, which will make it expensive. This looks like motorcycle ignition unit, probably from a Honda or something, and that's an issue because in its installation position, it's right up where you've got connections and the coil. I think you could possibly get this damp because if you've got a hatch over the back to deal with all of this, it could drip, and then you have salt water on the HT unit, which can then drip down onto the ground, so the whole engine becomes live, and you might get electric shocks off touching the engine because you cannot guarantee it's earthed to the seawater unless you've got a hull anode connected to this. You could still get shocks from it. So that is different. The Vire is embedded inside. You'll see you can't actually get to the HT coil. It's inside this cavity at the front of the engine. It's unlikely to get wet, and unless you literally half sink the boat, then you'd get seawater in there. But in normal use, if you threw wet sails over this or something, it's not got the ability to short the HT lead out onto the engine. So I'd be a bit concerned about that. This is a Series 2. That means it's got a reversing gearbox and a simple control panel. Apparently the Mark 1s didn't have this. You had, in order to get reverse, you had to stop the engine put another big switch over into reverse and restart the engine, and it would run in reverse, the whole engine then. And owners complained that it was all very neat because you didn't need a gearbox. But sometimes they would stop the engine when they wanted reverse, like they were coasting towards their pontoon, and there wasn't enough battery, or it wouldn't start in reverse, because of course the propeller is now twirling round in the forward direction. It's going to resist reversing if the boat is moving forward. So that caused problems, no doubt collisions, which is why they ended up sticking this £1,000 gearbox on the back instead. So this is the Mark II, and apparently the Mark I didn't have a water-cooled exhaust, so it couldn't use the rubber easy hoses that we like. It had a noisier, hotter, solid exhaust pipe all the way out, which must have been quite noisy and difficult to install. So I've got back to my checklist here. This is my comments. So the head gasket fails. That's the biggest problem I can see with the engine from design. And the alloy head itself corrodes, which is a very expensive part to buy and machine. The size is a little bit bigger for the horsepower. The Vire 12 or 7 is 2 inches lower in height. It's a little bit less width. It's about the same length. So that's an issue, because it means that on a lot of boats designed for a Vire or a small inboard, this HT cap is going to end up very close to the cockpit floor level, which could be dripping wet, and then short out the HT by dripping down here, especially if these get cracked or abused or aren't fully waterproof. I've seen this before. Same with the HT lead, very close to the condensation that might form on top of the roof. If you've got wet bilges, it's going to condensate on the underside of the plastic floor, and then it will drip down on the top of these places. With the Vire, the 7s, the spark plug is right at the front, and it's 2 inches lower, so there's no HT problem there. With the 12, it's at a 45-degree angle. It's hardly any, well, it's not even higher than the engine. So more clearance for your HT there, makes it easier to change plugs. Weight is about the same. They're saying in the book 54 kilos. I reckon it's about 48, but I may have got that wrong. I was just using my scales. The Vire is about 55, but with the Dynastar it's a little bit heavier. I think the Dynastar is about 9 kilos. As I said, I didn't like the pump drive belt reliability. I'd question that because it's so thin. The pulleys will corrode, and I think it might even slip as well as snap. The alternator performance must be down, and subject to corrosion. The exhaust manifold is alloy, heat exchanger, and I reckon that's going to have lots of corrosion. The exhaust injection downpipe is also alloy with possibly corrosion. I've heard from Stuart in Scotland the main bearings are unobtainable, he said to me, and were very expensive. I haven't looked, but that would be a big concern. The Vire's very easily available in stainless steel ones as well that won't rot, and not that expensive. They're very susceptible to damage, he said, because when one cylinder starts leaking, the engine carries on and pumps seawater down inside the engine and rots these main bearings. So that's something a Vire can't do, because even if, well, a Vire doesn't have a cylinder fault, but if it did have a leak, it couldn't, I mean, I've never heard of this, but if a Vire had a crack in the cylinder wall on the inside and it pumped it into the cavity, the engine would just stop because there's only one cylinder, and then you wouldn't rot out your main bearings slowly over hours and hours of use not knowing. But this is one of the problems with twins. They keep going if they've got a cylinder fault, but that can start pumping salt water all over the place. I'd be concerned about the starter and relay corrosion because it's right below a load of drip points where there's hoses from the pump and manifold. Looks like it's from a motorcycle or a Mitsubishi unit. The carburetor, I'm questioning the power they claim. Did they really test it independently on a dyno for this 12 horsepower, or 16 I'm reading in some manuals? It's only got a 23mm opening, this Amal Aresh carb, and I know I've spoken to Tillett's and technical team and others, and basically they will tell you that a small throat carburetor won't give you enough power if it's too small. The ignition is dangerous being external, using motorcycle coils, and it needs lumination. So it's rather an expensive system compared to the Vire. That's a great thing if it works, but it needs 12 volts, doesn't it, lumination? So how can you start this engine on a flat battery? You can't. Even though they haven't got a pull start on the front like the Vire, you can put a rope cord in there and pull that on a flat battery because it's got magneto ignition. You just pull start, it doesn't stop the engine firing. With lumination it requires 12 volts, and apparently there's an emergency only belt start. So I imagine you wrap some cloth around here a few times and hope it doesn't get caught in this pump. You've got a huge load of an alternator in here geared up, and 2 cylinders to fight against instead of 1. So with the Vire you can get the thing just after top dead centre and pull it round quite easily. But with this being a twin, there isn't an easy third of a rev or so. You can't go round 2/3 till you hit compression. It's going to be maybe easier. Could be more difficult though, I think, to pull start. So there's that issue. What else have we got here? Yeah, there's no pull start unless you use a flat belt. I don't think it's going to start on a flat battery with lumination. The engine mounts are not rectangular. The rear ones are offset. That's because of the gear lever and starter. So because they've got the starter inserted here, they've put the engine mounting leg aft of that, which is fine. Now you would have thought they put the corresponding one exactly the same length on the other side, but they can't because you've got the gear stick in the way. So what they've done is they've put this one forward about 2 inches so that it doesn't obstruct the operation of the Hurst gearbox that they added later. So that means when you install this engine, you've got to mark out the positions and not a rectangle, but there's a different one on the port rear thing, which must make it a little bit of a headache. Not a big problem, but obviously a bit of a peculiarity that'll take more time. The oil mixture is 40:1, the Vire is 50:1. So I'm wondering why they wanted a bit more oil. Probably because this main bearings were degenerating and extremely expensive, and also probably it's coped a little bit better if there was a weep on the cylinder gasket. It would have protected it a little bit better. The Morse Teleflex is inaccessible with the carb being aft. As I've said, that is, unless you have a rear hatch on that engine, it's going to be very, very difficult to adjust the gear and throttle settings. It's all hidden behind. There's this very loose pivoted lever here. I don't know if this is original equipment, but it looks very crude, and that's going to corrode like hell. That's not even a stainless steel cable, so that will corrode and seize. You'd need to get that. And even if the gear linkage didn't corrode up, the adjustment for the carburetor throttle and its operation looks rubbish to me. With the Vire, it's really nice, and right where you can get your hands at it on the front. Yeah, this ignition doesn't seem to be adjustable at all. It's breakerless, it says, but what about the accessibility and adjustment of it? There's no screws or anything. You can't adjust the timing, so I suspect that this is just an off-the-shelf modular thing, like the gearbox and the starter from different manufacturers, that they put this lumination on there, and the position of this sensor hopefully suits this particular model. But I've seen this before where the timing isn't optimized and the engine can be easy to start but doesn't give its full horsepower and overheats slightly because of the way the ignition is timed. So it would have been nice to have some adjustable thing. I'm not saying it isn't adjustable, but I can't see where it is adjustable. What really worries me is that salt water can get down that hole. There's a cavity down there. It's not sealed off or potted at this hole, so that would fill up with condensation and salt water quite easily. And then what's the consequences of that? I don't know. But if getting that filled up with salt water is gonna cause an ignition problem, to rectify it is nearly impossible, because this is part of the engine. You'd have to take off the flywheel, the front pulley. You'd have to disconnect this engine mounting from the engine. Then you'd have to lever up the engine on blocks. Then probably you could get to these bolts to pull that cover off. There'd be a gasket under there, and probably the front oil seal for the crankshaft, which you'd have to be careful not to damage, or you'd have to put new ones in, all to get at that sensor which is filled up with salt water. So I'd be very nervous about that. I think every owner should be thinking about putting silicon sealant in here just in case. Maybe that's a bad one that I've got. So finally, a note on this 2-year guarantee from new. Why only 2 years? They knew about this gasket problem and the head rotting. And I know from Volvo MD owners, because I do a lot of dyno starts for them, that the weakness of those engines is the cylinder head gets rotted where the seawater goes through its jackets, and on a diesel it's higher compression than this, and eventually the barrier between the high pressure explosions and the low pressure seawater fails. This gets rotted away on a Volvo MD, and it's about £1,000 for a new head on one of those. So usually it's such an old engine, it's thrown away just because the head rots too easily. Now they've got a similar problem on this Dolphin, but it's not as high compression, but because it's made of aluminium and it's got a joint, it's going to fail. So I'm sorry, but this really was only ever going to be reliable in freshwater, like a motorbike engine might have been like this or something, or could be used on lakes. So in summary, it's a real novelty of an engine. I'm fascinated by it. I've heard about these for years. It's the first time I've actually had one, and it wouldn't take a lot to get it running. I'd probably have that head professionally welded, so there wouldn't be any air bubbles in it. I think that can be done and planed off. It'd be expensive. Like I say, it's 500 quid for a new head plus the machining, but that could be repaired and got running. But I'm not sure it would be reliable, because you've always going to have a dissimilar metal interfaced with a non-high pressure sealing gasket. So probably you'd have to change the gasket every 2 years to keep that reliable. I don't know. There's an awful lot of work to rebuild this because of all of the joints and faces, and there's so many aluminium parts. Once they're disassembled, I'd want to clean them up immaculately inside, not just outside. And putting some kind of paint finish on these bits that's going to last is nearly impossible, because it's getting hot, you've got salt water everywhere, and there's junctions with dissimilar metal. So I don't think it's going to be easy to find one which hasn't got the paint flaked off like this one, but that's the way I like to do things. Yeah, interesting engine, which the purpose of this is to learn, is there anything that you could learn from this engine to benefit the Vire? And my conclusion is no. The only thing I like is the quality of the gearbox, that it's a separate bolt-off unit. You could probably change that quicker than the Vires, and it doesn't actually drive the pump, but it's very expensive. So I think if you solve the Vire's problems with the pump shaft and impeller quality, you don't need that. But yeah, I like the twin cylinder idea, that if one cylinder misfires it keeps going. That is an advantage, because on a Vire, if you get a dirty spark plug, the engine stops. And sometimes you need a bit of revs to blow the crap out of the spark plug's gap. I think this only happens if you don't have proper fuel filters in. From my experience, 6 years of running a Vire, I had a lot of problems with it cutting out until I put a desalinating fuel filter in with a 10 micron filter. I never had a problem again. So having 2 cylinders is better if you've got dirty fuel. Yeah, potentially maybe that does kick out 20 amps or more. That's an improvement, but I wouldn't want to do it with an alternator that could corrode. That is an issue. And I think the lumination is a good idea if it's bulletproof, and solving that problem, that would be better. So maybe I'll take this apart and see how they've done the sensor. I could learn something there. But no, I don't like the front pump. You have to gear it down. It's got reliability issues of its own now, so it might be easier to change the impeller, although you could burn yourself on these hot bits if it was just run. But I can see it's going to be more unreliable, because if this belt isn't adjusted right or breaks, it stops the pump. That can't happen on a Vire. The pump's driven by the crankshaft directly. So as long as the engine's turning, so is the impeller, or at least its hub if you've got a bad one. Yeah, cool. Modular approach to a boat engine. Of course, this is all impossible today to manufacture new because it's two-stroke. They've banned them. You can rebuild these things, and let's be honest, the environmental discussion is a separate issue for another video. But in reality, I'd just like to say that these leisure boat engines are only used for about 100 hours a year. That's almost no pollution if you added up the number of cubic meters of CO2 and the little bit of oil that goes on the water. If this was a commercial fishing boat, I would be concerned. But a leisure boat, about 100 hours a year. And compared to that, if you threw this out and put in a new diesel that's supposed to run cleaner, Well, you're probably still only going to use it for 100 hours a year. So maybe you're producing half the pollution for those 100 hours, sure. But what about the pollution in the factory that made it? And the pollution of melting down the engine for scrap? You can avoid that by rebuilding the engine, can't you? And putting something reliable in there, which is a two-stroke rebuilt. So I think there's still a market for that. There must be absolutely huge amounts of CO2 produced in the casting foundries and all of the machinery. There's about 1,000 parts on these engines, which all get machined with electrical driven things and power stations feeding them, and massive amount of indirect pollution as well. So I really wouldn't like to see a brand new engine replace a two-stroke in a leisure boat. But times are changing. I hope to do another video on that. But it's been great fun looking at this Dolphin, and if they could solve this barrier, it might have been a much better engine today. I can see back in the late 70s or 80s, was it, they launched? It would have been wonderful because it hadn't started failing when they reviewed it. But imagine if you went and reviewed 10 random Dolphin engines today, probably 9 out of 10 would have had serious problems with this failing. And the ones which hadn't is because they've hardly been used, or they're used in fresh water. So not really a saltwater marine engine. What would be the solution? Could they put an aluminium cylinder barrel on there? Because then you'd have similar metals. You could line it with a steel liner pushed in, and then you could have a high compression seal gasket with a better seal then. I don't think that would be such a problem. Maybe barking up the wrong tree. Or have a cast iron head. Then you've got two similar metals. This is like an old Austin engine, isn't it? A sort of 1920s. You'd have a cast iron head and a cast iron pot. And I had an Austin Somerset once, 1954. That had similar things. Had a cast iron head, cast iron gas. It had a solid copper gasket, I remember, and it's quite nice and squashy copper. So it could be the solution, but you've got all these other aluminium bits on the engine, so I think the whole engine is destined to rot and corrode after about 10 years anyway. But maybe the owner would be happy with that. Seems a short-term thing. A lot of the boats which have got these on now, of course, are 1970s boats, so they're 50 years old nearly now, and must be causing a problem. The only other Dolphin I saw, coincidentally, well, not, was like this. The cylinder head was removed and the owner had given up on it. It was a salvaged boat, I think, in a boat just waiting for a new owner. And when I saw the engine, it had no top. I think it was a Mark 1, because I don't remember all this gearbox and alternator gear. And it had a great big cylindrical front thing, I think, with lots of electrical coils and things, and a complex panel for the starting, so almost certainly a Mark 1. But that looked like this, head off, barrels rusted, and the owner had abandoned it. So obviously it was a problem with the Mark 1s as well. And that was 20 years ago I saw that. So it's a continuing problem for them. And they need to solve this, not have a joint here. Could they have done it with a one-piece casting? Why couldn't they have done it? If Vire Valmet could do that, why couldn't Dolphin do a one-piece cast iron cylinder and head? It must be possible. That might be a solution as well. So you throw this away, throw that away, and you supply the owner with a new casting, which is just a one-piece design. Yeah, it would be a good solution for this. I think Dolphin should look at that. Obviously you can't do these engines new, as I said, because they're 2 strokes, but you could supply an upgraded part, which is a 1-piece casting with the head and the cylinders together. It would solve a lot of this, wouldn't it? Anyway, that's the end of my video. Hope you enjoyed it. Don't often do things on other engines, but this is very similar. I think you'd have to conclude that the Vire is going to last longer, and it has lasted longer than the Dolphin. And what you've got is simplicity with the Vire, where you've got complexity with the Dolphin. And according to the owners, the nice thing about it was it ran smoother because it was twin cylinder, and they didn't report a lot of problems with gearboxes or pumps being difficult to service in the early days. But all of the owners have reported cylinder failures that I've heard of, so that's killed the engine after about 1 or 2 decades. So I won't tell you what to do, but my opinion, I wouldn't buy a Dolphin engine without expecting to do major work on the cylinder head every couple of years, even if it was running nicely. But if it had a Vire in it, I would ask them, has it had the pump shaft and impeller upgraded? And has it got stainless steel main bearings? Possibly. If it's got all that lot, and all of my concourse engines has, that's a really good engine. It's going to last another 40, 50 years. So, do you want an engine that's going to last 50 years or an engine that's going to last a few years? 2-year warranty from new that had. Amazing. Cool. Anyway, thank you very much.